Welcome to the Terra Firma Energy Burtonhead Road gas generation project. In this presentation, we will cover what is gas peaking, we will give a general project overview, we will cover the phases of the development of the site, we will go through how the site will operate, and we will go through the revenue streams for the site once operational. Gas peaking technology is required to help satisfy the demand for electricity on the grid when the demand outweighs generation. With the removal of large-scale coal-fired generation plants from the UK's national grid, our dependency on different sources of generation has increased exponentially. Renewable generation technology has advanced a long way in recent years, however, it is still wholly reliant on favourable weather conditions. Solar is now a lot more efficient with the development of PV technologies, however, solar generation still outputs on a curved scale, with maximum generation in the middle of the day for a short period. Traditionally, the highest times of demand on the grid in the UK are the evenings. This means that solar generation doesn't often feature as a source of generation at peak times. Both onshore and offshore wind have seen an increase in production which has provided the grid with a large amount of generation, but like solar, it is dependent on having the correct conditions. With these limitations in mind, the grid is dependent on additional generation assets that can be called on to meet the demand. Peaking stations are important because they can produce large amounts of power using only a small footprint at a sustained output for as long as required. Without peaking technology, the UK will not be able to transition to renewable generation as its sole source of power. The Burtonhead Road gas peaking station was acquired by Terra Firma Energy as a shovel-ready project. This means the project already had planning permission, a grid connection and a gas connection. The image in the top left is a 3D model of how the site would look if it was built from the plans that were submitted to planning. As part of the technical due diligence, a few engineering changes needed to be made, and the image in the centre of the screen is the most up-to-date and current layout as the site is being built. The construction and development of the project is broken down into 4 main stages. Stage 1 being mobilisation, Stage 2, civils and groundworks, Stage 3 is installation, and finally Stage 4 is the commissioning of the site. The mobilisation phase is crucial to the project development. In this phase, we carry out the ground clearance to allow us access to the site, and the Stage 2 ground investigation study. This is a penetrative study in which samples are taken to give us the makeup of the ground below the site. This is the primary driver for the civils design, as it will tell us the load bearing capability of the ground below. As a condition of the planning permission, we were required by the Coal Mining Authority to carry out rotary drilled boreholes down to 30 metres to ensure that the coal seam below the site had no unrecorded workings on it and that the ground was stable. There was also a requirement identified by our arboricultural survey that we would need to remove the trees that bordered the site, as the site's lifespan is 25 years and the trees only had an expected lifespan of an additional 15. After the successful completion of the mobilisation phase, we moved into the civils and groundworks phase. The first part of the civils phase was to clear the ground and prepare it so that construction activity could begin. This involved the breaking out of the concrete which formed the base of the majority of the site. This presented us with an opportunity to bring a crusher onto site and recycle that broken concrete, which gave us over 1,400 tonnes of reusable crushed stone. Once the site had been suitably prepared, we moved into the civil engineering phase of the civils and groundworks. This consists of the construction of all the foundation bases for all the plant that is to be installed on site, from the engines to the transformers to the chimney base. As part of the groundworks, a 3-tier duct run system had to be installed on site. These ducts will carry the high voltage export cables, the low voltage power cables, and the communication cables between the switch room and the generators. As you can see from the overview pictures at the bottom, the civils and groundworks phase consists of the majority of the complex works of the site. Once the civils and groundworks phase had been completed and all the foundations were in place, we moved into the installation phase. The first part of the installation phase was the offload and connection of the gas metering pressure reduction skids. These reduce the incoming gas from the intermediate pressure main in the road down to the operating pressure of 256 millibars for the engines. The next items to be installed as part of the installation phase are the power transformers. The large transformer is the primary grid transformer, and that changes the voltage of electricity from the engines from 11,000 volts to 33,000 volts to match the point of connection substation. The smaller transformer is an auxiliary transformer and changes the voltage from 11,000 volts to 400 volts, and that will provide the site's low voltage supply. Following on from the power transformers, we moved into the delivery and offload of the 10 Cummins generator sets. Each of these generators weighs 40 tons and was lifted by a 200-ton crane. We will now cover the operation of the plant once commissioned. Gas is fed from the transmission network at the connection point on the road into the pressure reduction skids. These skids reduce the pressure of the gas from intermediate pressure to the operating pressure of the engines. This gas is then fed along the underground gas network on site and into the gensets. The generators then burn this gas, which helps drive an alternator at the forward side of the gensets, which generates electricity at 11,000 volts. This electricity travels along the underground cable network and into the switch room. From the switch room, it's then transported into the primary grid transformer. This primary grid transformer will change the voltage from 11,000 volts to 33,000 volts, so it matches the connection point. The 33,000 volt electricity then travels under the road into the Scottish Power switch room by the front gate of the site. From the Scottish Power switch room, the electricity travels out onto the DNO network at the point of connection. The Burtonhead Road gas peaking plant will have two sources of revenue. The primary source of revenue will be energy trading, which will see the plant generate electricity at peak times for up to 2,500 hours a year. The modelled sale price for electricity is at £75 per megawatt. The reality, however, is that the site will not generate electricity for anything less than £170 per megawatt, with the wholesale market price regularly reaching in excess of £300 per megawatt at peak times. The site's gas supply will be provided by EDF Energy, who are also the electricity off-taker. The benefit to using EDF Energy in this way is that the gas purchase price will always be less than the electricity sale price. Alongside EDF Energy, we have appointed an optimizer called Newstream Energy. Their function is to ensure that EDF Energy are calling for power at times of maximum profit, and they are incentivised by a percentage of the profits that they secure. The second source of revenue comes from the capacity market contract. The capacity market mechanism was put in place to ensure sustained electricity supply in the case of emergencies. With the shift to renewable sources of power generation, the frequency of capacity market events is increasing. Burtonhead Road Power has secured a capacity market contract that will pay a standing fee of £550,000 per year for being connected to the grid on standby. If a capacity market event is called, then the plant will generate electricity at the wholesale market price for as long as it is required by National Grid. This will not affect the 2,500 run hours for the site. It is important to note that during a capacity market event, the wholesale electricity market price can raise in excess of £3,000 per megawatt. The Burtonhead Road Power gas peaking plant is now entering the final stages of the installation phase. Once all of the plant has been successfully installed on site and has been connected to each other, we will then move into the final phase of the project. This will involve the commissioning activities of the site prior to energisation. As we look forward to the Terra Firma Energy pipeline, the next project that has begun development is the Miners Road Power Project in North Wales. This site will comprise of 20 megawatts of gas peaking, complemented by an additional 3 megawatts of battery energy storage. The entrance of the development site has been earmarked for 10 EV charging points. As a total pipeline, Terra Firma Energy currently have 350 megawatts of power generation assets at different levels of development. The portfolio includes 250 megawatts of battery energy storage, 60 megawatts of gas peaking, and 40 megawatts of ground-mounted solar. These additional technologies open up new revenue streams for the sites and diversify the Terra Firma Energy portfolio. Once the Terra Firma Energy pipeline has been successfully built out over a period of 3 to 5 years, it will be one of the strongest portfolios on the market.